Let z1 equal 3 minus 4i and z2 equal 1 plus 2i, where I squared is equal to minus 1. Part A, plot z1 and z2 on the argand diagram over. So this is our real axis, this is our imaginary axis. Part B, from your diagram, is it possible to say that the modulus of z1 is greater than the modulus of z2? Give the reason for your answer. So z1 is 3 minus 4i. So what we do is we go to 3 on the real axis, that's 3, and we go to minus 4 on the imaginary axis, that's minus 4. We join them up, and we plot the point z1. So 3 minus 4i. Then z2 is 1 plus 2i. So we go to 1 on the real axis, and 2i on the imaginary axis. So 1 plus 2i gets us to here. So we plot the point z2. So 1 on the real axis, 2 on the imaginary axis. Part B. From your diagram, is it possible to say that the modulus of z1 is greater than the modulus of z2? Well, modulus means the distance from the origin being the centre point here. So is the distance of z1 to the origin greater than the distance of z2 to the origin? So if we're to join up z1 to the origin, and then if we join up z2 to the origin, we can clearly see that the distance from z1 to the origin is longer than the distance from z2 to the origin. So the answer is yes, the modulus of z1 is greater than the modulus of z2, and the reason is the distance of z1 to the origin is greater than the distance of z2 to the origin, and we can use a ruler to check. So we can measure these two lines. Part C. Verify algebraically that the modulus of z1 is greater than the modulus of z2. So we're going to use our modulus, or our distance formula, which is the square root of a squared plus b squared. And we're going to start off with z1. We're going to get the modulus of z1. So we have a big square root, and we put the real part, which is 3, into brackets and square it, plus the imaginary part, which is minus 4, into brackets and square it. Very important that we use brackets. 3 squared is 9, minus 4 squared is 16, 9 plus 16 is 25, and the square root of 25 is 5. So the modulus of z1 is 25, or the distance of z1 to the origin is 5 units. Then we're going to find the modulus of z2, which is 1 plus 2i. So again, we're going to have our big square root. We're going to put the real part, which is 1, in brackets and square it. We're going to put the imaginary part, which is 2, in brackets and square it. 1 squared is 1, 2 squared is 4. 1 plus 4 is 5, and we get the square root of 5. So the modulus of z2 is the square root of 5, or the distance of z2 to the origin is the square root of 5 units. And 5 is clearly greater than root 5, so 5 is greater than root 5, so we have verified algebraically that the modulus of z1 is greater than the modulus of z2. Part D. Find z1 divided by z2 in the form of x plus yi, where x and y are elements of the real number set. So we need to do z1, which is 3 minus 4i, divided by z2, which is 1 plus 2i. So we have 3 minus 4i divided by 1 plus 2i. So when we're dividing complex numbers, the rule is we multiply the numerator and the denominator by the conjugate of the denominator. The denominator in this case is 1 plus 2i, and the conjugate of 1 plus 2i is going to be 1 minus 2i. So to get the conjugate of any complex number, we change the sign of the imaginary part. So in this case, we have plus 2i, so that plus becomes a minus. If it was originally a minus, it will become a plus. So we end up with 3 minus 4i multiplied by 1 minus 2i divided by 1 plus 2i multiplied by 1 minus 2i. So we multiply the top and the bottom by the denominator with the opposite sign. So that plus becomes minus. So now I'm going to multiply out the top. So 3 minus 4i multiplied by 1 minus 2i. I'm going to break up my first bracket. I'm going to bring down the 3 and stick on the second bracket. And bring down the minus 4 and stick on the second bracket again. 3 by 1 is 3. 3 by minus 2i is minus 6i. Minus 4i by 1 is minus 4i. Minus 4i by minus 2i is plus 8i squared. Careful with this, a minus by minus is a plus. And I by I is I squared. And bring down the 3. Minus 6i minus 4i is minus 10i. And that I squared becomes minus 1 with brackets around it. 8 multiplied by minus 1 is minus 8. 3 minus 8 is minus 5. And minus 10i stays as minus 10i. So just make sure that you always have the real part first. So you get minus 5 minus 10i for a numerator. So this multiplied out to become this. Now we're going to multiply out the denominator. So 1 plus 2i multiplied by 1 minus 2i. So again, we break up this first bracket, we bring down the 1, we stick on the second bracket, we bring down the plus 2i, and stick on the second bracket. 1 by 1 is 1, 1 by minus 2i is minus 2i, plus 2i by 1 is plus 2i, plus 2i by minus 2i is minus 4i squared. A plus by minus is a minus, 2 by 2 is 4, I by I is I squared. We bring down the 1, minus 2i plus 2i cancels out, and the I squared becomes minus 1 with brackets around it. Minus 4 multiplied by minus 1 is plus 4. A minus by minus gives a plus. 1 plus 4 is 5. So our denominator multiplied out to give us 5. So our numerator is minus 5 minus 10i. And our denominator is 5. So minus 5 minus 10i over 5. We see that 5 will divide into each of our terms. So 5 minus 5 divided by 5 is once. Minus 10i divided by 5 twice. 5 divided by 5 once. So you get minus 1 minus 2i. So this is our final answer, minus 1 minus 2i. The real part comes first, the imaginary part comes second.